Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to the course on computerized methods. Computerized methods for engineering. Okay, so this is our course. Okay, Turki Hasibiye. So this is a course which details about how we can solve the mathematical things, especially in a way which is understandable for the computers. So basically, you have to refer the main textbook for this course, which is prescribed in the syllabus, is the numerical methods textbook. It's numerical methods. Okay, numerical methods by R.V. Dukhipadi. Okay, this is easily available, 2010 version. Okay, and it's by the New Age publishers, New Age International publishers. Okay, so this is the textbook for this course, and the reference book, another book is there as a reference. You can use this as the reference book. That is the introduction to numerical analysis using MATLAB. So in this textbook you can see a lot of examples and programs related with the MATLAB by using MATLAB by Rizwan Butt. This is the author in 2009. Similarly, another authors are there. Johns. Okay, sorry, not author. It's the publisher, Johns and Bartlett publisher. Okay, so these are all the textbooks for this course. So in this course, basically you will be studying about the solutions to linear equations. That means you have already seen what is linear equation in the higher secondary classes. So here we will be seeing how we can find the solution of the linear equations, and what are all the numerical techniques, that means what are all the computational techniques. Okay, you can see here the name of the course is Turki Hasibiye. So it's the tariq, or the way to compute the solution which is understandable for the computers. So you can program this procedure in the computers and you can find the solution. So the first topic that we will be studying is the solutions to the linear equations. Okay, these are all the topics. So there are subtopics inside these, and we will be studying about the solutions to nonlinear equations. Okay, solutions to nonlinear equations, and mainly another one is the solutions to differential equations. You know what is differential equations. So all these solutions, whatever we are saying about all these solutions, are obtained by using numerical techniques. So we will be obtaining all this solution by using numerical techniques, or a set of procedures. We can say it is nothing but a set of procedures. If we follow those procedures, we will be getting the solution to the equations. Okay, whatever it may be, linear equation, it can be nonlinear equations, and it can be differential equations. So we will be seeing those set of procedures. Okay, so first of all we will be discussing about the solutions to linear equations. Okay, so I will be directly going into the solutions of linear equations. So before that, I will be first discussing what is the set of linear equation. Okay, what is set of linear equation? You know that we have a set, we have the equations in two variables. Let us assume equation in two variables. Okay, we can assume the equation in two. We can consider the equation in two variables. Okay, let us consider one equation, x plus y is equal to 3. Okay, this is one equation number 1, and another equation is x minus y is equal to 4. Now, to find the solution, you know that we have a procedure, that is, either you can add the equation or subtract the equation. Let us add the equations. Let us add the equation 1 and 2, that is x plus y equal to 3 and x minus y is equal to 4. Okay, x minus y is equal to 4. Now, if I add this equation, I will get 2x. You see here, plus y minus y, this is equal to 0, this is equal to 7. So what is my x? X is equal to 7 by 2. It is nothing but 3.5. So I got the x, and I know that x minus y is equal to 4. So I know that x minus y is equal to 4. You see here, by using this equation, x minus y equal to 4, and I know x is equal to 3.5 minus y is equal to 4. So what is my y? My y will be, I can move this guy here and I can move this 4 here, so it will be 7.5. Okay, so I got the solution. So you see here, my x is equal to 3.5 and y is equal to 7.5. It is not the solution. I think there is some mistake here. You see here, okay, I will be proceeding like this. You see here, x is 3.5 minus y is equal to 4. So I will move this guy here, so it will become plus y, and I will move this 4 here, it will become minus. So 3.5 minus 4 is equal to y. So y will be equal to minus 0.5. So that is the solution. So x is equal to 3.5 and y is equal to minus 0.5. So you see here, that is the solution. It will be satisfying this equation and this equation. You see here, if I put x is equal to 3.5, so 3.5 x plus y is equal to 3. So 3.5 plus minus 0.5, it is equal to 3. It is satisfying this equation. Now x minus y, so x is equal to 3.5 minus 0.5. That means 3.5 plus 0.5. That is equal to 4. So it is satisfying both the equation. So a solution should satisfy all the equation. So the solution should satisfy all the set of equation. Okay, it is the solution. So you see here, this is an equation that I have considered. I will rewrite it again. You see here, my equation is x plus y is equal to 3 and x minus y is equal to 4. X minus y is equal to 4. You see here, this is my equation. So I can represent, and this equation you see here on the right hand side, it is not 0. It is not 0. Okay, it is not 0. And this kind of equation are called non homogeneous equation, non-homogeneous equation. So please remember these names. Non-homogeneous equation. Okay, it is non-homogeneous equation. Suppose if I take another example, you see here x plus y is equal to 0 and 2x minus y is equal to 0. You see here this equation right hand side is 0, and this kind of equations are called, these two equations, the set of equations are called homogeneous set of equation. Homogeneous means same kind, so it is homogeneous equation, homogeneous set of equations. Okay, so you see here the first one is not homogeneous. It is because you see here that is not 0, that's why it is not homogeneous. But in the second case, you see here this is equal to 0, so it is known as the homogeneous equations. So we have two kinds, so equations. So if the right hand side is 0, you see here it is the homogeneous, non equal to is the homogeneous equation. So you can see here, okay, I will consider an homogeneous equation. I will consider an homogeneous equation. You see here x plus y is equal to 0, 2x plus 2x minus y is also is equal to 0. So this equation, you see here, if I put x is equal to 0 and y equal to 0, definitely you can see here that it will satisfy both the equation. That means it will satisfy, if I put like this, it will satisfy both 1 and 2. That means equation number 1 and 2. That means you see here, if I take equation number 1, 0 plus 0 is equal to 0. It's okay, fine, right? And if I take equation number 2, it is nothing but 2 into 0 plus 0, again it equal to 0. It is satisfying. So for homogeneous equations, what is the conclusion? For homogeneous equation, all the variables equal to 0 is a solution. It is also a solution. If you have a homogeneous equation, if you have another example, let's say x plus y minus z equal to 0, 2x plus 3y minus 4z is equal to 0. If you have 2x minus 3y plus 8z equal to 0, and this is the set of homogeneous equation, because all the right side everything is 0, you see here. So it is showing an homogeneous equation. You see here this is homogeneous, okay, homogeneous equation. Now if I put x is equal to 0, y equal to 0 and z equal to 0, it will satisfy all the equation. It will satisfy all equations. That is equation number 1, 2 and 3. 1, 2 and 3. So x is equal to 0, y equal to 0 and z equal to 0 is also a solution to this, So for homogeneous equations, that's what I have told you. For homogeneous equation, all the variables is equal to 0 is also a solution. So it is a solution to homogeneous equation. There may be another solution also that we will see later. Okay. Now let us consider another example, the same example that we have seen before. X plus y is equal to 3. I think that's it. X plus y equal to 3 and x minus y equal to 4. X minus y equal to 4, right? So this is one example. So we will see how to plot this. You see here, by using equation 1, I can write my y as 3 minus x, and by using equation 2 I can write my y as x minus 4. Am I correct? Okay. Now, so I will use a different color for equation number 2. I will use the red color. You see here y is equal to x minus 4. Okay. Now, you see here I will plot this graph. So x 0, 1, 2, 3, 4, 5. Okay. This is minus 1, minus 2, minus 3, minus 4, and minus 5. And here 1, 2, 3, 4, let's say. And this is minus 1, minus 2, minus 3, and so on. Okay. And this is the x-axis and this is the y-axis. So I am going to plot my equation number 1. So I am going to consider the equation number 1. So if x is equal to 0, y is equal to 3, right? If x is equal to 0, if I take this equation x and y, if x is equal to 0, you can say that y is equal to 3 minus 0, it is 3. If x is equal to 1, then y is equal to 3 minus 1, that is equal to 2. So that's enough for plotting. So when x is equal to 0, y is equal to 3. So this is the point. This is the point with x is equal to 0 and y is equal to 3. Okay. Now, when x is equal to 1, y is equal to 2, right? So when x is equal to 1, y is equal to 2. This is 1 and 2, right? So I have got 2 points. That is enough for plotting this equation. So I can plot like this. Okay. This is my equation. This is an equation of a straight line. You can see here. Okay. Now the second case, you see here I take this guy. So I have x and y. If I put x is equal to 0, then y is equal to 0 minus 4. It is minus 4. So if I put here x is equal to 0, y is equal to minus 4. Okay, sorry. I will just rewrite this equation because I cannot plot here. So x minus y is equal to 2. I will use this. So here also it will become 2. Okay. No issues. Okay, I have just changed the equation with another equation. So you see here, when y is equal to, when x is equal to 0, y is equal to minus 2. When x is equal to 1, y is equal to 1 minus 2. 1 minus 2 is minus 1. So when x is equal to 0, y is equal to minus 2. So 0 and minus 2. This is the coordinate. This is the point. Now when x is equal to 1, y is equal to minus 1. So this is another. So this is another point, that is 1 minus 1. So you see here I got 2 points, so I can draw the line. So this is the straight line. Now where is the solution? That's it. You see here, this is the equation number 2, sorry. This is the equation number 2 and this is the equation number 1. You see here both the equations are crossing at some point. Though the equations are crossing at some point, and this point is the solution. That is the solution. So that's what we are going to find out by adding or subtracting 2 equations, and we got the solution. So here you see here in this equation, if I add this 1 and 2, equation number 1 and 2, I will get 2x is equal to 5. So what is x? X is equal to 5 by 2. So it is nothing but 2.5. Then by using equation 1, I can get my y as 3 minus x, which is equal to 3 minus x means what? 3 minus 2.5. What is my x? 2.5. So it is 0.5. So I will be getting 0.5 as my y. So you see here I am getting exactly here this point. This will be 2.5 and okay, I will be getting this point as 2.5 and my y, you see here I will be getting it as 0.5. That's what the solution, that's what I am getting by solving this equation. So the same thing I am getting here, you see. So the solutions are, you see here, this is x is equal to 2.5 is the solution, and y is equal to 0.5 is the solution. So x and y. In case of, so this is a non-homogeneous case. You see here, this is a non-homogeneous because homogeneous. Okay. You see here, there is no solution which is 0, 0. Okay. When x is equal to 0 and y is equal to 0, if that is the solution, then you can say it is homogeneous, or we cannot say it is homogeneous as such. But you see here, definitely x is equal to 0 and y is equal to 0 will be a solution to to homogeneous equation. But this equation is not homogeneous equation. Okay, so we will see an homogeneous case. X minus y is equal to 0, 2x plus y is equal to 2x minus 2x plus 3y is equal to 0. So this is equation 1 and 2. Now you know that definitely this is homogeneous equation, homogeneous equation. Okay, homogeneous equation. You see here, this right hand side is 0. So if I put x is equal to 0 and y equal to 0, that will be a solution. That will be a solution. Definitely these equations will be crossing through the origin. That's the meaning. So we will see how we can plot it. Okay, so let's say this is 0, 1, 2, 3, 4, 5 and 6. So this is minus 1, minus 2, minus 3, minus 4, minus 5. So this is minus 1, then minus 2, minus 3, this is 1, this is 2, this is 3 and 4. Okay, now I am going to plot these equations. Okay, I will be using a different color for the second equation. Second equation I will be showing as the red, and the first equation I will be using. So first equation, okay, x is equal to y. If x minus y is equal to 0, what is the meaning? Y equal to x, that's the meaning. So x and y. If x is equal to 0, y is equal to 0. If x is equal to 1, y is equal to 1. That's the meaning. Okay. So it's a straight line through the origin. You see here, when x is equal to 0, y equal to 0, x is equal to 1, y is equal to 1. So it is a line with 45 degree. Okay. That's it. So this is the equation 1. Now we will talk about the equation number 2. This guy. You see here, y is equal to minus 2x divided by 3. Am I correct? So you take here, how we are getting it? We can see here 2x plus 3y is equal to 0. So 3y is equal to minus 2x. So y is equal to minus 2x by 3. So this is the equation. Okay. Now we will see, I will plot it here. There is no space. So x and y. So when x is equal to 0, y is equal to 0. No issue. So this is a point. Now when x is equal to 1, y is equal to minus 2 into 1 by 3. So it is minus 2 by 3. So minus 2 by 3 is here minus 2 by 3. Y is equal to, when x is equal to 1, y is equal to minus 2 by 3. Minus 2 by 3 is less than 1. So it's somewhere here. Okay. So that's it. So you see here, this is the equation 2. So what is the solution here? You see here the solution is 0, 0. X is equal to 0 and y is equal to 0. That's the solution. So this is the homogeneous equation. Okay. So I hope that this is very clear to you. Now we will see, we will take another example. x plus y is equal to 4, okay, and x minus y is equal to 3, okay. So this is an example. Now I told you that this is a non-homogeneous equation. This is a non-homogeneous equation. So in two variables, okay, variables. So I can represent by using this as a matrix also. You see here, I will put here y here and x here and y here like this. After that, I will take the coefficient here. You see here the coefficient here, it is 1 into x. This is 1 into x. So I can take like this, its coefficient is 1. And this is 1 into y, that means the coefficient is 1. Next, here again it is 1. Okay, 1. And here the coefficient is minus 1. This is equal to 4 and 3. Now you see here, I can easily, if I multiply this, so this I can represent this as A, and this as the matrix. You can see this can be, you can consider this as a matrix X bar, and this is the matrix this is the matrix B bar, okay. So you see here A into X bar is equal to B bar, okay. So you can represent like this. Instead of x and y, instead of x and y, we can use the variable x1 and x2. And instead of this 4 and 3, I can use the variables. This I can represent it as b1 and this is b2. So in general form, I can represent like this, okay. A11 into x1, okay, I can represent like this. X1 plus x2 is equal to b1, okay. X1 minus x2 is equal to b2. Or I can represent, this is x1, this is x2. So the same thing, I am going to represent it as 1, 1, 1 minus 1 is equal to b1 and b2, which is nothing but this is the matrix A and this is the matrix X is equal to B. So this is another notation. So this anyway, any method, any kind of notation can be used, okay. I hope this is clear to you. Now in three variables, equations in three variables, let's say x1, x2, x3 are the three variables, and the coefficients another are the three variables. Let's say we consider one equation, x1 plus 2x2 plus 3x3 is equal to b1, okay. X1 minus 3x2 plus 2x1 2x3 is equal to b3. Now x1 plus 5 x2 plus 4 x3 is equal to, this is b2 and this is b3, okay. I can represent it by using a matrix of 3 by 3 matrix. I think you have already studied about the matrices. So I can write like this, and my right hand side is b1, b2 and b3. Now I need to fill the matrix. You see here the coefficient, it is 1, 2 and 3. 1, 2 and 3. Next is 1. Next this is minus 3 and this is 2. And here it is 1, 5 and 4. So this is how we can represent, okay. So this is the matrix A and this is the matrix X and this is the matrix B, okay. So AX is equal to B, okay. That is, now we will see, so this is a set of equation. So if B1 equal to B2 equal to B3 equal to 0, then the equation is called homogeneous, okay. Homogeneous. So you see here you have already seen that this equation is an equation of two variables. So the equation of straight lines is something like this, straight lines. So it is straight lines, equation of lines. But here you see here, this is a equation of three variables. So it is not lines, it is planes. Okay, so three variables, it is talking about the plane. Okay, so that's it. Now we will see how we can view these equations. You can see here there is one equation here, x minus 5y is equal to a, and another equation is 4x minus 2y is equal to b. Okay, so here b1 is a and b2 is b anyway. So you see here, if I change the a, the equation, you see here the first equation, that is the red color, it is showing in the red color, it is moving, right? So if I put my a as 0, you see here the equation is actually passing through the origin. You see here this equation is passing through the origin, that is the red color equation line is passing through the origin. Now if I put my b is equal to 0, it also will pass through the origin. Okay, it also will pass through the origin. So the solution, obviously the solution is 0, 0. Okay, so if I put, so then it will become homogeneous equation. So this is the nature of homogeneous equations. These homogeneous equations will be passing through the origin. Suppose if a is not 0, okay, something like 4.5, now they are having it is not both are not the homogeneous equation. Okay, now you see here, where is the solution? You see here, this is the solution. If I take this point, you see here it is minus 0.5 and minus 1. That is the solution. That is the meeting point is the solution. Similarly, for the planes, the solution is the meeting points of the planes. That means you will be having three things, x, y and z, or x1, x2 or x3. So if I change this, you see here the solution also will be changing. So here if I change my b, the solution is now here. Okay, so this is the solution, 1.694 and minus x is equal to 1.694 and y is equal to minus 0.561. So this is the straight line. Okay, anyway, so the equations of the straight line, we are using two equations and finding the solution. That is, we are finding the meeting point. That is the meaning of solution. So here you see here, when a is equal to minus 4.1, the solution also changes. Now the solution is, the meeting point is 2.65, x is equal to 2.65 and y is equal to 1.35. That is the solution. I hope this is clear to you. So that's it. Now we will see the basic matrix operations. Okay, let us assume that you have a matrix operations. We will see the matrix operations. So before proceeding, I will just give you some review on the matrix operations. So let us assume that you have a matrix 1, 2, 3 and 5 and another matrix which is equal to 1, 0, minus 1 and 2. Okay, now addition, we are talking about addition. Okay, addition, that means a plus b which is equal to c. So what is c? C is equal to a plus b. So it is 1, 2, 3, 5 plus 1, 0, minus 1 and 2. So this is nothing but you just need to add only the corresponding elements. So 1 plus 1, it is equal to 2. Next is 2 plus 0, it is equal to 2. Now 3 plus minus 1 is minus 2, not minus 2, it is 2. Now 5 plus 2, it's become 7. So this is a plus b. Similarly, if 3 by 3 matrix is there, you can do the same procedure. The same thing like addition also. So for the subtraction also, for the subtraction, you can see here c is equal to a minus b. Okay, so it is nothing but 1, 2, 3, 5 minus 1, 0, minus 1, 2. So it is nothing but 1 minus 1 is 0, 2 minus 0 is 2. Now 3 minus minus 1, 3 minus minus 1 is 3 plus 1 is 4. Now 5 minus 2 is 3. Okay, that's it. Got it, right? So that is the matrix subtraction. Now we have another thing. Matrix subtraction is over. Now what are the indices? What do you mean by the indices? Let us assume that there is a matrix A which is represented as A11, A12, A13, A21, A22, A23, A31, A32 and A33. Okay. Now you have another matrix which is represented as B11, B12, B13, B21, B22, B23, B31, B32 and B33. So what do you mean by this C is equal to A plus B? And what is the C? C can be represented as C11, C12, C13, C21, C22 and C23 and C31, C32, C33. Okay. Now addition that we have seen, Cij can be written as, I can write like this. For example, if I add these two matrices C equal to A plus B, then I can represent like this. C11 is equal to A11 plus B11. C13, for example, 12 is A12 plus B12, or in general case Cij, okay, I and j can be 1 to 3 is equal to Aij plus Bij, right? So if addition or subtraction, if it is subtraction, then it's become minus also. It can be plus or minus, okay, according to your operation. So I hope this part is clear to you, right? So that is it. Okay. Now what do you mean by the determinant of the, sorry, before that I will talk about the multiplication of matrices. Okay, let us assume that multiplication, let us assume that a matrix is 1, 2, 1 and minus 1, and B is 2, 1, 0, 1. Okay, then A into B, we will call it as AB is equal to 1, 2, 1 minus 1, 2, 1, 0, 1. Okay. So how to multiply this? That's the procedure. That's what we are going to explain. So here you see here, I will take the first row and I will take the first column. Then I will multiply the first number index, that is 1 into 2, 1 into 2 plus, now I will take 2 into 0. So 2 into 0. So this is the first element. Now I will take the first column, first row and the second column. Then that means first row, you see here I will be taking first row and the second column. That means 1 into 1, 1 into 1 plus 2 into 1, 2 into 1. Similarly, I will use another color. You see here, if I want the second row, then I have to take the second row from here, and second row and first column element. That means I will take the first column. So 1 into 2 plus minus 1 into 0, minus 1 into 0. That's it. Now I can use like this. If I want the second row, second column, this one, that means I will take the second row and second column elements. So 1 into 1, that means 1 into 1 plus minus 1 into 1, minus 1 into 1. So that's it. So this is nothing but, the result is nothing but You see here 1 into 2 plus 2 into 0, it is nothing but 2. 1 into 1 plus 2 into 1 is 2 plus 1 is equal to 3. Now minus 1, that is 1 into 2 plus 0, that means minus 1 into 0, that means 2. Now 1 into 1 plus minus 1 into 1, 1 plus minus 1 is equal to 0. So this is nothing but A into B. Okay, so I am going to calculate C, which is equal to A into B. So this is how you can multiply two matrices. Okay, so don't use the calculator for this, for simple multiplications. Okay, now another thing regarding the matrix is the determinant. Okay, determinant. Let us consider the matrix example 1, matrix A 1 1 2 3. Okay, the determinant of matrix A is usually represented like this. Now what I will do, I will cross multiply this. So 1 into 3, then minus, okay, 1 into 3 minus this guy, 2 into 1. So this is nothing but 3 minus 2, which is equal to 1. So this is the determinant of this matrix. This is how you can define the determinant of matrix. Okay, now another thing, okay, determinant, but we will talk about the determinant of the matrix in more detail later. So we will explain about the minor. Okay, we will explain about another concept which is known as minor of a matrix. Minor of a matrix. Let us consider a matrix 1 1 2 and 3. Okay, this is the, okay, 1 1 2 and 3. Now this can be written as, it is a matrix with A11 A12 A21 A22. Okay, A21 A22. Now what is the minor of this matrix? That's what we are going to explain. What is the minor? Let's say the minor is represented as the minor is represented as M. Okay, let us consider M11, that is the minor. Usually it is represented like this, M11. So what we will do, if I want to find M11, I will take the element A11. Okay, then I will remove this row, I will remove that row, and I will remove that column. Then what is remaining? It is nothing but A22. Got it? Now we will consider another minor, M12. So what I will do, I will take the element, I will use another. So what is the A22 in the previous case? A22 is 3, right? Now I will again write it 1 1 2 3, I think so. This is the matrix. Yeah, so I want to find, this is nothing but A11 A12 A21 and A22. You have to remember this index you see here. Now what is the minor? M12. That means I will, if I talk about the minor M12, I will, this is the 1 2 position, so I will remove all this row and column. It's not this column, sorry. I will remove this column and row. So what is remaining? It is nothing but A21. A21 is nothing but 2. Okay. So I am using a notation for the determinant here. Why it is so, that I will explain. So what will be similarly, if I talk about the minor of this guy element, that is M21, it is nothing but, it will be 1, right? Similarly, the minor of M22, that means I talk about this guy, it will be again 1, right? So that is the minor. So this is for easy for a 2 by 2 matrix. Okay, now there is another thing which is known as the Okay, that this is easy for a 2 by 2 matrix. So I hope this is clear to you. The remaining lot of things are there for the 3 by 3 matrix. We have some more rules, so that I will explain in the next lecture. Thank you.